right, so we're here to start a new week talking about nutrition. So nutrition, and more specifically plant nutrition. Okay, so introduction to plants and plant nutrition. I could just read the introduction. Okay, all right, let's look up the introduction. This is going to be on page 2. Have you thanked a green plant today? Reads a popular bumper sticker. Indeed, we should thank green plants for providing the food we eat, fiber for the clothing we wear, wood for building our houses, and the oxygen we breathe. Without plants, humans and other animals simply could not exist. Psychologists tell us that plants also provide a sense of well-being and peace of mind, which is why we preserve forested parks in our cities, surround our homes with gardens, and install plants and flowers in our homes and workplaces. Gifts of flowers are the most popular way to acknowledge weddings, funerals, and other events of passage. Gardening is one of the fastest growing hobbies in North America, and the production of ornamental plants contributes billions of dollars annually to its economy. Human history has been strongly influenced by plants. Ever since the availability of land and water for cultivating plants has been a major factor in determining the location of human settlements. World exploration and discovery was driven by the search for herbs and spices, the cultivation of New World crops, sugar, cotton, and tobacco was responsible for the introduction of slavery to America, the human and social consequences of which are still with us. The push westward by English colonists into the rich lands of the Ohio River Valley in the mid 1700s was driven by the need to increase corn production and was a factor in precipitating the French and Indian War. The Irish potato famine of 1847 set in motion a wave of migration, mostly to North America, that would reduce the population of Ireland by half over the next 50 years. I can recall as a young university instructor directing biology tutorials in a classroom that looked out over a wooded area. I would ask each group of students to look out the window and tell me what they saw. More often than not, the question would be met with a blank, questioning look. Plants are so much a part of our environment and the fabric of our everyday lives that they really register in our conscious thought. Yet today, faced with disappearing rainforests, exploding population growth, urban sprawl, and concerns about climate change, the productive capacity of global architecture or global agriculture and forestry ecosystems is put under increasing pressure. Understanding plants is even more essential as we attempt to build a sustainable environment for the future. The Green World series opens doors to the world of plants. This series describes what plants are, what plants do, and where plants fit into the overall circle of life. In this book, you will learn about the nutrients that plants require and how they obtain them, the intimate relationship between plant roots and soils, and how plant nutrition affects the nutritional quality of the food you eat. Introduction of plants and plant nutrition. I believe a leaf of grass is no less than the journey work of stars. Introduction to Plants and Plant Nutrition, Sally's Science Fair Project. When Sally's biology teacher told her class that they must perform long-term experiments for this year's science fair, she was elated. Even though it was only a few weeks into the school year, Sally's teacher had been focusing on plants as the first part of the class, and Sally loved plants. Her family lived on a farm in the country where her dad grew soybeans, sweet corn, and hay for their beef cattle. They also had a large garden for growing their family's food, and Sally earned part of her allowance by helping in the garden. Based on her practical experience on the farm and in the garden, Sally was not surprised when her teacher began to talk about the obvious requirements for plant growth: water, light, and air. When her teacher spoke about other requirements of plants, essential mineral nutrients, she was intrigued. She knew that her dad spread fertilizer on their fields, and she had, much to her dismay, helped to add manure to their home garden until it improved the soil. She had never really considered the scientific basis for these farming practices and thought that a science fair project about plant nutrition could teach her more. After class that day, Sally talked to her teacher about doing some basic experiments on the nutritional requirements of plants. After some research in the library, 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 in the library, library, and consultation with her teacher, Sally decided to test the effects of different kinds of soil, different watering regimes, and the requirement for light, water, and air. She went home that night with a lot of work before her. The plant way of life. Plants via photosynthesis are the providers of energy for virtually all of the terrestrial organisms in the world. Photosynthesis performed by plants is the critical step in energy conversion from the sun, taking carbon dioxide from the air and using water and light to make sugar, which is the starting material for all organic matter. The breakfast you ate today, whether eggs, cereal, or bacon, was derived ultimately from plants. Plants also produce the raw materials for the clothes you are wearing, whether cotton, polyester, or leather. The home in which you live is likely constructed with plant materials, and the page on which these words are printed is formed largely of plant matter. Plants are the world's air conditioning systems, the purifiers of streams and rivers throughout the world, the primary generators of atmospheric oxygen, and the storage providers of over 90% of the world's terrestrial biomass. Plants are the single most important group of terrestrial organisms for energy capture from the sun, and the vast majority of all terrestrial organisms depend on plants for food, shelter, or both. Most terrestrial life is dependent on plants and their ability to form organic compounds from inorganic constituents. To accomplish this, plants require chemicals called essential nutrients to carry out photosynthesis and thus produce energy. Though photosynthesis is a marvel both biochemically and energetically, it also comes with certain costs in terms of the lifestyle that terrestrial plants can successfully pursue. To survive and reproduce, plants require water, air, light, and relatively small amounts of other nutrients. Furthermore, plants are sessile organisms. They grow in one place and cannot move about freely. This is in stark contrast to an animal that might scamper off to a new location if its current habitat becomes uncomfortable or undesirable. The only way a rooted plant can move is to grow into a new position, and the process of growth requires the expenditure of energy. To live in a single location in some cases for thousands of years and gain all the necessities for life is one of the great challenges that plants face. Energy capture and nutrition. Every plant growing in the world is engaged in a slow but bitter struggle to overcome the limits of its circumstances and make a living from light, water, air, and small but critical amounts of mineral from the soil. Biologists break organisms into two broad categories on the basis of how they secure their food. There are those organisms that eat other living or once living creatures and plants. These are called Heterotrophs. Heterotrophs include animals, fungi, most bacteria, and most protists. The other group, called autotrophs, is made up of organisms that are able to produce their own food using energy from some other source, such as light or higher energy sulfur compounds. They include plants, algae, uh, cyanobacteria, purple sulfur bacteria, and relatively few others. Autotrophs can be separated into two smaller groups: chemioautotrophs and photoautotrophs. Chemioautotrophs produce their food using chemical energy, and photoautotrophs produce their food using light energy. In the case of virtually all life on Earth, the fundamental building block is the chemical element carbon. Carbon compounds are also the primary energy source for heterotrophs. Carbon occurs naturally in the environment as carbon dioxide, but this form of carbon is not usable by heterotrophs because there is very little energy stored in carbon in this form. Autotrophs, however, readily use carbon dioxide because they have the mechanisms for elevating this fuel. Although heterotrophs cannot use carbon dioxide, they must use high energy carbon compounds produced by autotrophs. Chemical constituents of the plant body. Photosynthesis, either directly or indirectly, consumes the vast bulk of the water transported through a plant. But water and its component elements are not generally considered plant nutrients. Furthermore, though 90% of the dry weight of a plant is made of carbon and oxygen, neither the carbon nor the oxygen of carbon dioxide are considered plant nutrients. Given that these elements, carbon, oxygen, and hydrogen, make up the vast bulk of the dry weight of a plant, what elements left and why are they important if they occur in such small amounts in the plant body? The full answers to these questions will unfold in subsequent chapters, but in short, the relative prevalence of an element is not necessarily indicative of its importance in plant biology. In some cases, the lack of even tiny amounts of a mineral can have significant negative impacts on the growth and life cycle of the plant. Okay. Oh, man. There are some 240,000 species of higher plants, and not all of the species will have the same mineral needs at the same scale. Some will require a special element in much higher concentration than others, and others will be able to tolerate a much higher concentration of an essential element that would, to a different species, be toxic. Such variability is inherent in biology, and for this reason, most generalities, such as the definition of an essential nutrient, need to have some wiggle room in interpretation. Nutrient deficiencies in plants are often made most evident by plant physiological responses that can be readily observed. Such a response is called a symptom. Nutrient deficiency symptoms tend to occur in three major patterns: localized to the younger tissues, localized to more mature tissues, or widely distributed across the plant. In each case, the distribution of the symptoms can help a person determine the nature of the deficiency experienced by the plant, or, if the deficient nutrient is already known, make an inference about the role the nutrient plays in the plant body. For example, in the case of deficiencies that result in symptoms in the youngest parts of the plant, one can infer that the nutrient in question is not easily mobile within the plant, and thus reserves the nutrient cannot be easily translocated to the areas of need. This inference is sound because plants almost always strive to protect and provide for their youngest tissues and the structures that give rise to them. Thus, if it were possible for the plant to move the nutrient to the young tissue, it would almost certainly do so. Firstly, if the symptoms of deficiency first appear in more mature tissues, it is reasonable to infer that the nutrient in question is highly mobile, and the plant, always seeking to protect its young tissues, sacrifices the health of the older tissues to protect the young growing organs. Evenly distributed symptoms can imply that the lack of nutrient is widespread and systemic, that it functions in a general rule equally throughout the plant body, or that it affects the health and vigor of the plant at a large scale. Common symptoms, common symptoms, common symptoms of nutrient deficiencies. A, a common symptom of nutrient deficiency is chlorosis, the yellowing of the leaves and other green parts of the plant. Often, chlorosis is first evident in the spaces of the leaves between the veins, and then spreads to the veins. In extreme cases, the entire leaf will become yellow, and eventually the plant may drop the affected leaf in a process called leaf abscission. Another common symptom of some nutrient deficiencies is an etiolated growth habit. This results in tall, spindly plants with few leaves and a high degree of internodal elongation. This symptom is also typical of plants that are grown in the dark, forced to rely on stored energy from the seed or roots until the plant can reach sun again. A similar pattern can be seen in plants that are deprived of certain nutrients. The converse of the tall, spindly habit of etiolated growth is the phenomenon of stunted growth. Stunted plants fail to develop normally and often have small leaves and very short or compressed internodes that result in apparent whorls of leaves with no stem apparent between them. Stunted plants often have greatly reduced productivity and are not vigorous producers of flowers and fruits, if they form them at all. A common and severe symptom of some nutrient deficiencies is necrosis, the formation of dead spots or lesions, often in the leaves where the plant cannot sustain life any longer. Herbivorous. That's a great word. Nature provides a free lunch, but only if we control our appetites. That's deep. I mean, I'm in a place now where I would really like to read more of this before I make an itinerary. I think I'm going to have to start doing less books per week because I want to read the whole book. With both positive and negative controls. No water, distilled water, nutrient solution, distilled water, nutrient water, no water, distilled water. Oh, dark, no air. Dark, air. Light, no air. Light, air. Okay. It's really complex. That is very complex. Okay. How about we just say do Sally's experiment from page 17? This is this is almost she have to do this? Is this compit this is this oh Where's her control though? I put stuff in the vacuum. All right. Yep. That's what we're going to do. Read as much as you like and do the experiment on page whatchamacallit, and then get a plant that and treat it well according to your findings. I mean, that's what I have for today. Get a plant pet and treat it well according to your findings. And then we'll be done for today. Making a copy. Edition. All right, the name of this book is Plant Nutrition. The travel is didn't come up with the travel. The study is experiment. Experiment from page 17. Yep. Uh, and from the full history and treat it well according to the findings in your your local plant nursery. Local plant nursery. Those things are struggling. Plant nursery is having a hard time. I'm searching for plant nursery specialists such as labor shortages, supply chain issues, and higher costs, aging workforce, lack of interest in local work, and stricter immigration regulations. Studies estimate that labor accounts costs, increased shipping costs, higher costs for retreating planting soil, plants taking a long time to grow. 5 reasons why your nursery will fail. What? Rude. itinerary doesn't make any sense. You go to a local plant nursery, you do the experiment. Am I getting snappy? I don't know. I just feel like plants need to be treated better, you know. But okay, that's it for today. Another week. I never shared my screen, really. Let me share the book that we're looking at today. This is the book. This is the experiment. I read quite a bit. Table of contents. And here's what we have for the itinerary. So take care. See you next time.